So after the initial brainstorming and students coming up with questions, of course, what I couldn't show before this, because there's only so much video that I can show in like 30 minutes, is that students are presented with the challenge and they come up with a list of questions after they brainstorm. And then they go to CoMPASS, and this is a short clip on how the teacher is facilitating. Sorry about that sound. I'm going to move on here and show a couple of small. I don't think I have the time to go through all of them, but I'll just include this whole class discussion, which is at the end of the unit. overall discussion after they've looked at pulleys, and the student just said that when we had more distance, we reduced the effort, which is one of the big ideas in the work and energy unit that students need to learn about. And this big idea, they go through all the simple machines, and it is reiterated several times, both in the hands-on experiments, in the simulations, as well as in the CoMPASS. And one of our professional development activities with teachers is to reiterate the big ideas and make sure that students are learning those and able to apply them in the different simple machines. So I could show some other videos, but I need to move on here. So I'll briefly talk about what our research questions have been. And there are several facets to this project, and I have 6 graduate students now working on different aspects of it. We look at how students learn from multiple digital text, which is linked. We also look at what effect simulations have on learning, whether students learn better by using simulations, and how do they do that, and how do teachers facilitate classroom discussions. I don't have the time to go into a lot of detail about the data, but we collect a lot of different kinds of data from the classroom. There's the pre and post test that all students take, and several of our teachers use the test to give a grade for the unit as well. Students draw concept maps at the beginning, in the middle, and at the end of the unit. And again, these are used for research purposes, where we have a coding rubric to analyze them in detail, but teachers have a quick rubric that they use also to give students ongoing feedback about what they're learning. We collect computer-generated log files, and I'll show you in a minute how we use that. We also videotape classroom activities, and these videos are used in our professional development, as well as to see how teachers are bringing all the big ideas and how they are facilitating a classroom, like what is the nature of the discourse. And we also look at discourse in student groups, where we analyze how students are constructing science knowledge. So there are several sources of data that we use. This is just a quick, through several studies in the past few years, we've found that students who've used our curriculum have performed better than the traditional business as usual classrooms. And we also have looked at the selective use of simulations, and this only gives a picture of the overall idea of the fact that simulations have been useful. But I think when we analyze this data in more detail, we also found that for concepts like work and mechanical advantage, using the simulations actually helped a great deal, because the relationship between work equals force times distance was something that students couldn't understand well in their hands-on activities because of the role of friction. So when the friction was zero, using this in a simulation, they really understood the notions and how the relationships between workforce and distances. As I said before, we've been using navigation in CoMPASS, and we have a graph